Hi everyone, welcome to the Eureka Math series. We're going to start with Module 2. The materials, you can find them at engageny.org. I'll leave the link to the materials in the description. So check it out if you need the materials. All right, so we're going to start with Module 2, Lesson 1. Okay. So this is, once again, this is Lesson 1 of Module 2 from Eureka Math. And then you can find the materials for this in the description. All right, so let's go ahead then and work on lesson number 1. Okay, so lesson number 1, interpret division of a fraction by a whole number. So we're looking, these are the classwork opening exercises. And what you're supposed to do here is you're supposed to pair with the group, pair with another student, work on them together, and then come back and see if you guys are able to do those on your own. All right. Now for our purposes here, I'm just gonna go through all the problems, and then if you need to pause, rewind, then you can do that. All right. So let's go ahead then and go to part A and part B. Part A is write a division sentence to solve which problem. So on part A, they want us to write a division sentence. Right now, we got one of the things to keep in mind, you guys, is that that's the traditional division symbol, right? So we have right there, we have the traditional division symbol, but for our purposes, division can also be written as a fraction. So for example, I can say 3 divided by 2, right? But I can also say it as a fraction. I can say 3 divided by 2. All right, so we're looking at that division. One thing to keep in mind though is that division means that you're making things smaller. So you're grabbing one item and then you're making it smaller. You're breaking it into smaller pieces. Or you have an item and then you're sharing it among, a group of different students. So to divide means to make smaller, right? Because you're breaking something into smaller pieces. Multiplication is the complete opposite, right? Multiplying means you get big. Obviously, we have a traditional multiplication symbol. Here in 6th grade, we start getting into some algebra concepts. So you might see the dot being used as a symbol for multiplication. You also will start seeing parentheses later on. But for now, we're just going to keep it simple. We're going to keep the regular, or traditional symbol for multiplication. All right, so let's go ahead and read this questions here. So I'm looking at the left side here. 8 gallons of batter. So I'm going to just write it right here, number 1. So 8 gallons of batter are poured equally into 4 bowls. So again, 8 gallons of batter. You're gonna divide. Now, sometimes when you have word problems, you gotta look at the when you have word. There are words that will give you a clue whether they're talking about a division, multiplication, are they talking about an addition, or are they talking about a subtraction? What are they talking about, right? So sometimes there'll be words that are going to give you that clue. In this case, poured equally means you're dividing, right? You're breaking something into smaller pieces. In this case, those 8 gallons of batter, you're going to divide it into 4 different bowls. So that's how you would do that. But when you look at the right side, now you're looking at the opposite, right? 1/4, right? 1/4 of an 8-gallon pail is poured out. So now they're asking you to multiply, right? So at the end of the day, right, 8 divided by 4 is the same as 1/4 multiplied times 8. So we're doing the opposite, right? Because at the end of the day, 8 divided by 4 will give you 2. 1/4 divided by 8 will give you 2. And we know this because we can make this 8 a proper fraction by putting a 1 under it. Then you just multiply 1 times 8, that will give you 8. Then you multiply 1 times 4, that will give you 4. And 8 divided by 4 is 2, you get the same answer. All right, so again, the 8 divided by 4 is exactly the same as 1/4 multiplied times 8. Because you're breaking that 8 into 4 equal pieces, which will give you 2. Or you'll get in that 1/4 and making it bigger times 8, which will also give you 2. Think about it, right? 1/4 plus 1/4 plus 1/4 plus 1/4, that's 1. That's times 4. But you're multiplying times 8. So if you got 4 more, that's times 8, and your answer is 2. All right? So let's look at number 2. Let me get a different color here so you can see. Number 2, then you get 1 gallon of batter is poured equally into 4 bowls. So 1 gallon of batter, so 1 gallon of batter poured equally, that's going to be the word that's going to tell me division, because that means making it smaller. So that's 1 divided by 4. And the answer typically, when the number, right, when you have the one item that you're breaking, but you're breaking it into 4 pieces, then you're getting 1 out of the 4 pieces, and that's your answer. All right, you're getting 1 out of the 4 pieces, and that's going to be your answer. All right. So there's that. Okay. Now, and on the flip side, it's the same thing, right? If you're multiplying, then you're gonna have 1/4. So 1/4 times 1, that will also give you 1/4, right? 1/4 of a 1 gallon pail is poured out. Well, if you're only pouring 1/4 of the 1 gallon, well, then you're only pouring 1/4, right? Because 1/4 times 1 will give you 1/4. All right. So you notice the opposites, right? So let's look at the third one. Let's look at number 3. Okay. So number 3. Let's look at number 3. It says 3 gallons of batter are poured equally into 3 bowls. So 3 gallons of batter are poured equally into 4 bowls. Now, once again, in this case, you will see that your answer is going to be 3 divided by 4, right? Because the 4 doesn't fit into the 3. So it's going to be a number that's smaller, right? So when you do it on the flip side says 1/4. Now you're getting your 1/4, right? This is number 3. Now, what you're going to do is you're going to multiply, right, of a 3 gallon pail is poured out. So now you're going to multiply it times 3, right? So what happens is like you're saying you have that 1/4 and you're multiplying it 3 times. Adding is like multiplying. So 1/4 plus 1/4 plus 1/4, that'll give you 3/4, right? And so that's your answer right there. So if you want to do a tape diagram of this, so then what you'll do is you are going to look at the second, you're going to look at the fraction, and you're going to basically say, okay, well, that means that I have 4 bowls, so 1, 2, 3, and 4, right? And in those 4 bowls, I got to be able to fit 3 gallons of batter, right? And those right there, got to be able to fit 3 into 4. So this is 1 bowl, right? 1 bowl. This is 1 bowl. This is 1 bowl. This is 1 bowl. That's 4 bowls, right? And so I got to be able to fit those 3 gallons of water into those 4 bowls. And so you got to be able to figure out what's the value of each one of those little squares. And then the answer is going to be 3/4, right? Because you got to be able to divide 3 by 4. So each one is going to be worth 3/4. So this is worth 3/4. This is worth 3/4. This is worth 3/4. This is worth 3/4. When you add them up together, you get 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. That'll give you 12/4. That would equal 3. And that's the 3 that we started with right there. All right? So just for reference. Okay, so we'll continue. Let's go to example number 1. Okay, so example number 1 says 2 gallons of batter is poured equally into 2 bowls. Then how many gallons of batter are there in each bowl? So obviously, poured equally, they're asking us to do a division. Poured equally. That means division. Gotta be able to read those keywords. Figure out what is it that they want you to do. You want me to multiply? Do you want me to divide? You want me to add? Want me to subtract? What do you want me to do? Right? So look at those keywords, because those keywords are going to tell you what they want you to do. So in this case, they're saying 3/4 of a gallon are poured equally, divided into 2 bowls. That's what they're saying, right? So in other words, if we do our tape diagram, right? We got 2 bowls, so nice and easy, right there, right? 2 bowls, and those 2 bowls, I'm gonna pour 3/4. That's what I'm gonna do, right? So in this case, I gotta figure out what's the value, right? What's the value of each one of those little squares so I can find my answer, right? And what's the value? Well, half of 3/4 half of 3/4 has to go into one of those little boxes, and the other half goes into the other little box. Okay, that's how I found my answer. Okay, so now one way to do this, there's a couple of ways to do this, right? Because you have to divide 3/4 by 2. So how do I do that? Okay, well, if you make the 2 a proper fraction, right? Now remember that we can't really divide fractions, but we can multiply them, and we can do what we call the reciprocal, right? So we can do 3/4. Okay, so we keep the 3/4, then we change it from a division to a multiplication. But when we do that, then we're gonna do what we call the reciprocal, right? Reciprocal, which essentially it just literally means flip, right? So keep the first fraction, 3/4, change this symbol from division to multiplication, and then flip the second fraction. Now my 1's in the numerator and my 2's in the denominator. So 3 times 1 can multiply across is 3. 4 times 2 can multiply across, that's 8. And this is my answer here. So this tells you that each one of these little squares is worth 3/8. It's worth 3/8. Okay, and that there's my answer there, 3/8. So the question is, how many gallons of batter are in each bowl? Look at what they're asking me. How many are in each bowl? Remember that each one of these little squares, it's one. This is one bowl. This is another bowl, and therefore about 3/8. So my answer would be 3/8. Whoops. My answer is 3/8 of a gallon of batter per bowl, right? And there's my answer there. I got my units of measurement, right? My units of measurement are gallons. We're good to go. All right, so let's go to the second one. Let's go to example number 2. Okay, so example number 2 says 3/4 of a pan of lasagna is shared equally by 6 friends. Again, shared equally there, that's the clue that's telling me division, divide, do the division. Okay, that's the clue right there. So then what do I gotta do? Well, what I gotta do now is I gotta say, okay, well, 3/4 of a pan of lasagna, I gotta share equally means I gotta divide by 6 friends. So divided by 6. And look at what they're asking me. What fraction of the pan will be each friend? Each friend. In other words, they don't want to know the total, they want to know the part, right? Each one of the friends, what's going to be the part per friend. If I only have 3, I don't even have one full pan of lasagna, right? Not even one, I have 3/4. And that 3/4 pan of lasagna, I got to divide it equally among 6 friends. Okay, so let me draw my 6 friends. I'm going to do a type diagram. So my 6 friends are right there. 1, 2, 3, 4, 5, and 6. Those are my 6 friends. Okay, now those 6 friends, among all of them, I'm gonna have to share that 3/4 of a pan of lasagna. So then how many is each one gonna get? Well, the way you do that, once again, remember the method that we use that we call the reciprocal? We can do that here too, right? So this is gonna be equal to, so we keep the first fraction, we change from division to multiplication, and then remember the 6 is a whole number, but we can put a 1 under to make it a proper fraction. Then we're gonna have to flip that one, and this 1 is the numerator, and the 6 is my denominator now. Well, again, this is called the reciprocal. There is a mnemonic device for this, which I'll go over in the coming lessons. But for now, just understand that you gotta flip the second fraction. It's called the reciprocal. So 3 times 1 is 3, and then 4 times 6 is going to be 24. Okay. Now, here's the thing that you guys gotta understand. Now, here, if you simplify, right, 1, right, you can simplify into 1 and 12, right? So 1/12. One of the things that you guys gotta understand is, and it's actually, wait, it's not 12. What's, so 3, 6, 9, 12, 15, 18, 21, 24. It's 8. It's not 12. So it's 1/8. So what that tells you is that each one of this little, each friend is gonna get 1/8. This friend's gonna get 1/8, 1/8, 1/8, 1/8, 1/8. Okay. So then I have to say each friend will get 1/8 of the pan of lasagna. Okay. All right. Let's do that. Okay. So now let's look at example number 3. So example number 3 says a rope of a length of 2/5 meters is cut into 4 equal chords. Okay, so once again, 2/5 cut into means you're gonna make it smaller, which means it's a division. Remember, division means you're making things smaller. Okay, multiplication is the opposite. Multiplication means you're multiplying, you're making things bigger. So 2/5 cut into means you're dividing into 4 equal chords, and that's the problem there. So they tell you what is the length of each chord of each. So they want to know the part, right? You got 2/5 of a chord, so you don't even have one full chord, right? You got 2/5 of a chord, and that 2/5 of a chord you got to break it even into smaller pieces of 4 equal pieces. So what's the length of each piece? Obviously, your answer is going to be smaller than 2/5, right? Because 2/5 is the chord that you have. You have to break that into 4 different pieces. So what do? Once again, do tape diagram, right? So you got your 4 pieces, 2, 3, 4. Close this. So those are your 4 pieces. And these 4 pieces, you're going to have to break them into, that is the length of the rope is 2/5. And 2/5, you're going to have to break it into 4 equal pieces. So what is the length of each one of these little squares? What is the length of, that's what they're asking you to find, the part. What is the length of each one, right? So what I like to do here, you guys, is this method, and we're going to call it keep. Okay, we've been doing this in the previous examples, but let's call this keep, change, flip. And the flip part here, that's also the reciprocal. Okay, so let's just keep that in mind. So how does this work? All right, so the way this works, once again, keep the first fraction, that's 2/5, change the division to a multiplication. So once again, keep the first fraction, change. Okay, so look, we kept, we change, and then we're flipping. Remember, there's in the 4, there's a 1. We're gonna actually make it a proper fraction by adding a 1 under. And now if we flip it, now the 1 is in the top and the 4 is in the bottom. And so now look at what happened. Now we flip the second fraction. See that? We flipped it. The second fraction, we flipped it. And now here's one more trick that I want to show you guys to make your life a lot easier than what it already is, right? When you look at the fraction, I already have it like this, right? You gotta look across, right? So for example, look at the 5 and the 1, right? Now remember, it's a multiplication. So look at the 5 and the 1, but also look at the 2 and the 4, right? Kind of like you're crisscrossing the fractions there, right? It's a multiplication. Look at them like this. Can you simplify the 5 and the 1? The answer is no. Both the 1 and the 5 are already prime numbers, right? But look at the 2 and look at the 4. The 2 and the 4 are multiples, right? They have a common multiple, and that is the 2. So the 2 you can divide by 2, you can cross it and make it a 1. The 4 you can divide by 2, you can cross it and make it a 2. So now you're going to multiply 1 times 1, that'll give you 1. And then 5 times 2, that'll give you 10, and that's my answer. So then that tells you that each one of these little squares is worth 1/10. So that original chord that measured 2/5, broken into 4 additional parts, each length would be 1/10, 1/10, 1/10. If you add them all up together, 1/10 plus 1/10 plus 1/10, well, you get 4/10, right? If you simplify this, right, the 4 can be broken in half, that'll give you 2. The 10 can be broken in half, that'll give you 5. Look at this. You see that? Same answer. That simple. It's that easy. All right? So, all right, you guys. Now, let's go to exercises 1 through 6. All right? 1 through 6. Because we're doing the similar thing, right? It says fill in the blanks to complete the equation, then find the quotient, draw a model to support your solution. Here's the thing. Fill in the blanks to complete the equation. But then the quotient means the answer, right? It's specifically the answer to a division problem. It's called the quotient, right? But then they also want us to draw a model. It's the same thing we've been doing, right? So what do we do here? So 1/2 divided by 3. First of all, we gotta say 1/2 divided by 3. We're gonna actually add the 1 under to make it a proper fraction. 3/1 or 3 divided by 1 is the same as 3, right? Because you can fit the 1 into the 3. 3 times this is 3. Right, we're just making that a proper fraction. We're not really changing any value. So this is equal to. Now you guys gotta remember my model. Remember, keep, change, flip, And flip, we talked about that this is the reciprocal. Okay? So then again, we are keeping the first fraction. The first fraction is already 1/2. Keeping that. We're changing the symbol from division to multiplication. Again, keeping this one, we kept the 1/2, change the division to a multiplication, and then we're gonna flip the second fraction. So now the 1 is gonna be on the top and the 3 in the bottom, or the 1 is the numerator, the 3 is the denominator. Look how the 3/1, it was flipped. Or in math, we call it the reciprocal. Now we can just solve the equation, right? Now that we have it as a multiplication. Remember, there's one more additional step. We can look, once you have it as a multiplication, then you can look at them across like this and like that and think, can they be simplified? The answer is no, because the 2 and the 1 are already prime numbers. They're the lowest they can be. The 1 and the 3, they're already low numbers. They're the lowest they can be. So all you do is just multiply across. So 1 times 1 is 1, 2 times 3 is 6, and there's your answer. Okay? So your answer is 1/2 divided by 3 is 1/6, and it makes sense, right? Why? Because think about it. They're telling you that you have 1/2 of something, right? Could be 1/2 of a pizza. So you don't even have a whole pizza, just half. And that 1/2, you're going to break it further into 3 pieces. Well, if you do that, then you're going to get 1 of 6 pieces, right? If you do a model, right, we'll do a model. We got the 3 pizzas, right? So do this right here. Simple enough. There's your 3, right? And that 3, you have to break it further. You have to give it a value of 1/2. That's how this works, right? So then what's the value of each one of those individual squares? Think about it. If we said it was 1/6, we said it was 1/6, we said it was 1/6. If you add those pieces together, it should match that 1/2, and it does, right? Because 1 plus 1 plus 1, it's 3/6. And 3/6 can be simplified because if you cut the 3 in half, that gives you, if you divide 3 by 3, because it's a multiple of 3, that would give you a 1. If you divide 6 by 3, again, because 3 is a multiple of 6, that would give you 2. And this 1/2 is exactly the same as this 1/2. So we know they match. Okay? Perfect. So there we go. I found my answer. And then there's also my model, right? My tape diagram. So I'm going to do the same thing on number 2. On number 2, you go 1/3 divided by 1 by 4. Okay? So let's go ahead and do this. So we're going to have 1/3 divided by 4/1. That's what we have. And remember, we're using keep, change, flip. So keep, change, flip. All right? So once again, we're going to keep the first fraction, keep the 1/3. All right? We're going to change the symbol from division to multiplication. And we're going to flip the second fraction. I got 4/1, which is 4. Now the 1's going to be at the top, 4 at the bottom. Okay? Now, think to myself, can they be simplified? No, because if I look at the 1 and the 4, they're already in their simplest form. And then the 3 and the 1, they're already in the simplest form. So nothing I can do there. All I have to do is just multiply. 1 times 1 will give me 1. 3 times 4 will give me 12. And there's my answer, 1/12. Okay? Let's check. Let's see if this is true. Right? So I got a tape diagram with 4 squares. Got to look at my second fraction. Right? Got to look at my second fraction. 4 squares. So got 1, 2, 3, 4. Right? And these 4, they have a value of 1/3. Right? So I said that each one of them was 1/12. That's what we said. So then this is 1/12. This is 1/12. This is 1/12. This is 1/12. If I add them all together, well, then that's 4/12. Right? Can I simplify that? The answer is yes, because they are both multiples of 4. 4 fits into the 4 one time, and 4 fits into the 12 3 times. It will give me a 1/3, and that's exactly what I had right there, 1/3. All right? Now, for the sake of time, you guys, I'm just going to do a simple keep, change, flip, and this last 3 examples. If you are not, if it's not clear to you how the tape diagrams, how the models work, go ahead and rewind the video, check it out until you understand. All right. If you have any more questions, just kind of drop it in the line below. I'll look at it and I'll answer the question if you have any more questions. All right. But for right now, for the sake of time, keeping this video a little under 30 minutes, I'll make sure just to kind of solve these problems using keep, change, flip. That's what I'm gonna do. Just keep, change, flip. Okay. Keep, change, flip. So once again, keep the 1/4. Change from division to a multiplication. Change to 1/5. Why? Because there's a 1 under the 5 to make it a proper fraction. So 1 times 1 is 1, 4 times 5 is 20. There's my answer. All right? That's it. There's my answer. The next one. Keep, change, flip. Again, keep, change, flip. And remember, flip is my reciprocal. All right? So again, keep the first fraction, got 3 5s, change the symbol from division to multiplication, flip. Remember, there's a 1 under the 5 because there's a whole number, so now the 1's at the top. All right, so 3 times 1 is 3, 5 times 5 is 25. Can that be simplified any further? The answer is no, because the 3 doesn't go into the 25. So that's my final answer right there, 3 over 25. Okay? All right, so there it is. Now, let's go to the last one. So in the last one, once again, I'm going to use my keep, change, flip. Okay, keep, change, flip. So keep, so I'm going to go ahead and keep the 1/5, the 1/5, keep the 1/5, change from division to multiplication, and then flip. Remember, there's a 1 under the 4, so flip to 1/4. Okay, again, keep, change the symbol, flip the second fraction. Keep, change, flip. Now just multiply across. 1 times 1 is 1, 5 times 4 is 20, that's my answer. That simple, that easy. Once again, if you need to see the models again, go back and look at how I did these models back here. All right? So let's look at the last one. The last one, we're probably going to draw a model just so you guys can see once again how the model was done. All right? Now, we have 3/5 pint of juice is poured equal into 6 glasses. So think about it, you guys. Think about this, right? So I got 6 glasses right here. So 1, 2, 3, 4, 5, 6. Right? Those are my glasses, right? I got 1, 2, 3, 6 glasses. Now those 6 glasses are waiting for some juice, right? But I don't even have 1 pint of juice. I don't. Right? That means there's gonna be little juice served in each one of those little glasses, right? So because what I can do in all those glasses, I only have 3/5 of a pint available to serve. So that means they're gonna get a small amount of juice. So now what I have to do is I have to divide the 3/5 by 6. Now I'm gonna use my strategy again. Keep. Okay, so once again, 3/5 divided by 6. That's what they're saying, right? 3/5 of a pint of juice divided into 6 glasses. Now once again, keep, change, flip. Remember, keep. I'm gonna keep my 3/5. Change. Okay, I'm gonna change it from division to multiplication. Division to multiplication. Okay, and then flip. Remember, there is a 1 under because it's a whole number. So I flip it to 1/6. Now I can just multiply across it. But wait a second. Before you multiply across, look at the numbers here. The 1 and the 5, the 3 and the 6. Can they be simplified? And the answer is yes, they can be simplified. Well, the 1 and the 5, they cannot, right? They're already as simple as they can be. The 1 and the 5, there's nothing I can do about those guys, right? 1 is a prime number, 5 is a prime number. There's nothing lower than 1, so there's nothing I can do about that. But look at the 3 and the 6. Are they factors of each other? Yeah, the 3. The 3 can be divided by 3, and the 6 can't be divided by 3. So if I do that, cross out the 3, make it a 1, cross out the 6, make it a 2. So then I multiply 1 times 1, that'll give me 1. 5 times 2, that'll give me 10. So there it is. My answer is 1/10. So therefore, each one of those 6 classes is going to get 1/10, 1/10, 1/10, 1/10, 1/10, 1/10. Now, if I add them all together, that's 1, 2, 3, 4, 5, 6, 6 over 10th. But wait a second, I said I only have 3/5 of a pint. Well, no problem, because what happens if I simplify that 6/10? If I simplify that 6/10, well, break the 6 in half, that gives me 3. Break that 10 in half, that gives me 5, and look at that. You see that? I got my perfect answer. So each one of those glasses is going to get 1/10. All right? So, you guys, let me know if you have any questions. Again, I'm going to leave the description or the link to the resource in the description if you need the PDF for this. If you have any questions, leave it in the comment, and I'll go ahead and answer it for you guys. You have this problem set. Again, you can do the keep, change, flip method. I also will recommend that you probably try practicing the model, because that's what 6th grade math is all about. The model. So make sure that you guys do that as well. All right. One more thing. I'm gonna be adding a couple of other videos, or continue with the series with Module 2, and then I'm gonna also upload from the other modules. All right. If you find it helpful, give it a thumbs up. All right. See ya.